Hi everyone, this is Group 27. I'm Olivia. Today we are here to give a presentation on how does TOGAF support the logistic industry with IoT solutions. The presentation is divided into the following parts: introduction, background and existing problems, how enterprise architecture with IoT solutions meets the challenges, methodology of our proposed architecture, relevant case analysis, and conclusions. Over the past few decades, the development and continuing evolution of the logistics industry have undergone revolutionary changes. Rather than being viewed as a supportive industry to other functional areas previously, now it has been regarded as a strategic industry on its own. With the arrival of Logistics 4.0, to enable a quick response to fluctuating customer demands and provide seamless customer experiences, the logistics industry intends to realize intelligent logistics through digital innovation. Meanwhile, with its indispensable functions to support healthcare, the logistics industry has a growing urgency to offer customers faster, more reliable, and safer logistics services. Especially under the influence of COVID-19, the continuous surge in patients has further promoted the proliferation of requests for necessary medical equipment, drugs, and so on. Under the pressure, the original architecture reflects its vulnerability in meeting the highly dynamic and uncertain logistics market demands and the rapid development needs of globalization and vertical integration, which make it urgent for logistics companies to design a more responsible, flexible, agile, and comprehensive enterprise architecture. Our presentation aims to provide a clear view of how the implementation of IoT-based TOGAF enables the future development of logistics industry and meet the challenges brought by COVID-19. By figuring out the research question, how we could leverage the TOGAF associated with IoT solutions to improve the future competitive advantages for logistics industry. Next, Simon will discuss specifically about the backgrounds and challenges of the logistics industry.
Focusing more on the logistic industry itself, it generally follows the 5 major steps: the logistic park, warehousing, transportation, trunk transportation, and end delivery. So it's basically that the logistic company receive and pack the order from other vendors and process each order at the warehousing stage. Afterwards, they transit those packages through transportation and trunk transportation stage to finally deliver the order to the end customer. As various steps and parties are involved within the process, integration through digitalization is considered to be very essential to enable efficient operation. From the data perspective, efficient data integration needs to be in place to handle the enormous data amount and information follow-up. Transitions from one step to another within the process is also necessary to achieve timely handovers and to ensure smooth connections between sector to sector. Additionally, accurate and in-time information exchange and data sharing is required through the alignment with the third party to enable the logistics industry to enhance a healthy business ecosystem. Especially under the COVID-19 situation, the lockdown restrictions have brought increasing demand to the logistics industry, so that some severe issues have gradually appeared into the public horizon that again emphasize the necessity for better digitalization solutions. There are 3 major issues discussed here, which are inadequate online platforms, limited information management, and insufficient response to emergency cases. For our first issue, the inadequate online platforms, since the past logistic industry required their customer information relied largely on manual work at places like local post office. Now with the lockdown restrictions, the current business structure is inefficient to support the increasing online orders to collect customer information and ensure an accurate real-time online operating process. Limited information management is another barrier, as the current technical support on logistic operating process cannot efficiently deal with huge operating volume, so real-time tracking and monitoring on products and information flow will not be accurate enough to guarantee regular executions on both the process and their connections with other parties. Additionally, any unpredictable situation may happen due to the pandemic, so the current ability to respond to emergency cases in real time is inadequate to support the logistic industry operation, as they need not only to respond to any government call, but also need to ensure real-time communication with third parties and effectively integrate the solution into the operating process. Overall, to deal with the above issues, we consider a new enterprise architecture needs to be built. Now I will pass to Sean to have more discussion on the basic concept.
Thanks for summer. So, how enterprise architecture with IoT solution is the challenge? I will mainly explain it from the four parts. Firstly, what is the enterprise architecture? Enterprise architecture is a relevant description model of an organization and what should be created to fulfill demand of an enterprise and management. Secondly, as the most common way to build enterprise architecture, TOGAF is flexible and enable an individual enterprise to choose or give up any aspect of the process if desired, rather than be rigid solutions that impose additional tasks. As the core of the TOGAF, ATM recommend iterative methodology for designing architecture and outline a step-by-step process for developing or changing an enterprise architecture. Here, we will focus on TOGAF ATM Phase C, which combines the data and application architecture of IoT, and Phase D aims to create a technical architecture. Next, I will talk about IoT with TOGAF. TOGAF is the perfect way to help IoT to develop a solid architecture to fulfill the data specification. Since IoT solution is highly data dependent, implementation of IoT solution could benefit from structure of TOGAF standard, as it would allow the development of solutions that look at the company as a whole and enable improve the flexibility and the agility. Lastly, why we want to use IoT solution in logistics. The IoT has a lot of potential in field of transportation and logistics because it can be catered to a wide range of transportation applications and needs. Logistics can improve flexibility and real-time efficiency use IoT. A general IoT-based framework could be used in the logistics company to reinforce the agility by enhancing real-time data sharing and process management. Finally, due to COVID-19, enterprise in logistics sector require more flexible, agile, and comprehensive enterprise architecture to provide a support for fighting against the epidemic. Thus, it can be said that IoT solution with TOGAF architecture is the best choice for the logistics. Now I will pass to Xueting to talk in detail about IoT-based logistic architecture.
Hi guys, I'm Xueting. This IoT-based logistic architecture is given in this section. It is an architecture which includes 5 layers to simplify the complexity management due to the massive data size. It aims to gather real-time data over the logistic network and can be securely exchanged between different parties. It can also be used for sufficient decision-making management related to the control of the transportation activities. 5 layers including application, core service, resource management, smart objective, and physical resource layers. Each layer is related to the stages of both the IoT and TOGAF structure. States 3 and 4 in TOGAF ADM are carried out as the foundation of this architecture. The physical resource layer manages the physical resources involved in the process, such as technical hardware acting in the physical part, and in the smart objective layer, all the physical objects and resources should be converted into smart objects by IoT technologies for better information interoperability before being managed by the cloud. The resource management layer performs as a cloud-based data center which processes, stores, and integrates data through production logistic resources via the Internet. The core service layer includes cloud-based services and transforming the real-time information into functional service. The application layer comprises the interactions among the logistics application level and the IoT platform software. Also, 3 infrastructure are adding to this model: the logistic framework cloud manufacturing infrastructure, smart cloud-based production logistic synchronization infrastructure, and the autumn real-time information infrastructure, adding to the top 3 layers to realize sufficient control and monitoring of dynamic process. The integration between the CM-based resource management infrastructure and the IoT real-time information sharing infrastructure facilitate the real-time information and sharing the data transforming, which effectively solve the common problems such as the inconsistent data in logistics companies. By applying this IoT-based solution, the existing challenges could be solved. The customer-oriented services are provided by CM to handle the dynamics and changing resources. Autom helps with the information transmitting and sharing process in the real time and enables better process control. The combination of the infrastructures not only allows for timely data integration among each layers, but also tightly connects the cloud-based resources and service together to enhance better interoperability throughout the architecture implementation.
In this session, we will expose an empirical case of blood supply logistics architecture with an IoT solution. In COVID-19, the unpredictable demand, frequent update of patient information, and limited time to save lives are information challenge to a blood supply. The IoT-based architecture enables the traditional blood supply logistics to be transformed into smart logistics, and it can integrate product, people, process, data together. And according to the structure mentioned before, our case will also explain from these 5 layers. First is physical resource, second one is smart objectives, third is resource management, the fourth one is core service, and last one is application. The first one is physical resource. Physical resource can be reflected in multiple aspects. Nurse in regional blood center collect blood, conduct blood tests, and distribute blood to hospital. And hospital blood bank also have professionals to manage blood banks. During transportation, each labeled blood bag will be transported to a destination with an infrastructure for transporting temperature-sensitive products. This equipment resource lay a good foundation for the implementation based on IoT architecture. And then, the smart objective layer. The smart objective layer of architecture is equipped with a series of IoT devices and tags for the required blood product. Radio frequency identification, we call RFID, and barcode are the IoT tags. They can quickly identify target and data exchange, so that each blood unit can be connected to the inventory system for product information. Specifically, our RFID technology is also used to ensure standards for blood transfusion management, prevent medical error, ensure the accuracy. And then the resource management layer. In the resource management layer, IoT technology promotes the exploitation of information and cloud data in blood transportation. And the aim of this layer is to improve blood utilization. Blood data service supports the operational decision-making in the blood supply chain management. The checking function supports efficient inventory management and then maintain the control at the real-time blood stock level. And the last one is application layer. The IoT-based application layer in the blood supply chain reflects the utility of data integration. The first one is checking. IoT solution provides a real-time blood motion checking to maintain the available resource and usage monitoring. The second one is identification and authentication. Identification assures accurate patient identification with matching blood product, prevent medical negligence. Moreover, authentication is a security protocol like a barrier to keep out those who don't have the authority to access patient information, preventing the losses of medical resource. Automatic data collection is based on RFID technology, we said it before, to collect data automatically from products and various operational process. The last one is sensors. Sensor can be applied to provide real-time visibility into temperature change. Blood is a perishable product and is very sensitive to ambient temperature. Therefore, repeat feedback from sensors make it possible to solve the problem before the blood is damaged. And this is our case analysis for the blood supply chain. Next, Olivia will give the conclusion and future research direction about our presentation.
To summarize, due to the increasingly prominent digitalization of the logistics industry and the challenges brought by COVID-19, the existing inefficient architecture can no longer meet the needs of the changing market demands. Under this situation, we identify 3 major challenges: inadequate online platforms, limited resource management, and insufficient response to emergencies. To fully address these challenges, based on TOGAF, This presentation adopts IoT-based architecture by analyzing its 5 layers and considering the application of CM and Automn in each corresponding layer, which improves the data integration among each logistics link. Although the block supply case demonstrates that the proposed architecture integrates the business processes on a real-time basis, implementing it in real life could be much more complex, as it requires alignment among multiple stakeholders. The future research can provide a more comprehensive intelligent architecture for the digital transformation of the logistics industry by considering the implementation cost and the adaptability of relevant laws and regulations. Thanks for listening. Here's our references.